Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, my topic for this morning will be this is a random topic, but it will be a topic on integration. And how do you call this? This is a long video format. This is a random topic. So, this will be an addition to my long video format topic, integral calculus, but I will be putting this on the mixed topics, random topics. Okay, let's proceed. My subject matter for this morning will be, it's May 11, 2024, right? This will be a problem involving integration and on the topic powers of sine and cosine. Okay, I will try to read the problem. This is a good practice for those who are taking up engineering, much more those who are currently taking integral calculus. Okay, evaluate the integral sine cube of twice theta times cosine cube of twice theta differential theta. We are asked to evaluate the solution of this one. Okay, let's try to bring out the solution. Rewriting the given integral, that is sine cube of 2 theta, cosine cube of 2 theta, differential theta. And they should be equal to. We write our solution vertically downward. All the equality signs are actually aligned, so if we try to see it, it's a good thing to see. Okay. To evaluate this one, we will be rewriting this one into a so-called product thing, right? It will be the integral of sine square of 2 theta, sine of 2 theta, cosine cube of twice theta, differential theta. I make sine cube of twice theta as the product of sine of theta times sine of theta. So I place all the things under a quantity so we could visualize it. Meaning to say this sine cube of 2 theta, I rewrite it as just the product of sine square of theta, sine of 2 theta. Because sine of 2 theta is actually sine of theta to the power 1. And if we try to expand this one, we will be using the laws of exponent. Same base, different exponent. So if we try to multiply this one, it should be sine of 2 theta. The power will be 2 plus 1, which is equal to 3. And same as this one. So actually, sine of cube of twice theta can be written as the product of sine square of twice theta, sine of 2 theta. If the power is 1, we don't have to place it. But it is understood to be 1. The only reason I place 1 so we could visualize in the sole addition of the powers, right? So I will remove this one now. It is understood that the power is 1. So 2 plus 1 will be 3, same as this one. Okay? After expressing sine cube of 2 theta as the product, we will be using the so-called trigonometric identities. That is, originally we got an equation sine square of theta plus cosine square of theta is equal to 1. Originally, right? But for the given problem, instead of just simply a single angle, this is twice theta, this is twice theta. So if we try to take the equivalent of this, sine square of 2 theta, the one given, should be equal to 1 minus cosine square of twice theta. So we will be replacing this one by this value here. We put it here. Is this. So the key to the solution is actually by using our knowledge of the so-called trigonometric identities. That's why trigonometry is a prerequisite of integral calculus. Without knowing these trigo identities, we could not solve the problem. So we replace this one by this value here. Then we try to expand. Okay? We'll do with the first one. The operation here are all product, right? So 1 times sine of twice theta times cosine cube of 2 theta differential theta. That will be the first one, right? So I will rewrite cosine cube first. Then I will write sine of twice theta. 1 is just 1. Then the last part will be twice theta. So the first one here is the product of 1 times sine of 2 theta cosine cube of twice theta differential theta. The second expansion, there are only two terms here. Cosine square, okay, multiplied by cosine cube. We will be using the laws of exponent. The power of cosine of twice theta here is 2, same base, right? This is 3, so it will become cosine to the fifth of theta, multiplied by sine of twice theta differential theta. This is multiplied by sine of twice theta differential theta. Actually, I separate the integral already. So the first one, I put an integral sign. The sign of the second expansion is actually negative, so this is negative. The integral. 2 plus 3 will be 5, sine of 2 theta differential theta. And actually, this two integration here falls under the integral of u to the n du. Okay? Where the value of u is, the value of n here is equal to 3. The value of n here is equal to 5. And for both the first and second integral, the value of u is cosine of twice theta. The value of the term inside the quantity. Cosine of twice theta, cosine of twice theta. So the verification for this will be same as this one. That's why I put an arrow here. Okay? So if we are to use the power formula, the value of u, the one that is enclosed by the quantity is actually u. And it is actually cosine of twice theta. Am I still on camera? And if we try to take or verify the value of du, du will be equal to, we'll take the differential of both sides. The differential of u will be du, and the differential of cosine of twice theta, the differential or derivative of cosine is negative sine. So it will be the sine of 2 theta, the sine of u preceded by negative sine. Okay, times the differential of the angle. Okay, the differential of this one is actually 2, and the differential of theta will be theta. So if we try to expand this one, it will be negative 2 sine of twice theta differential theta. This one here is the total value of du from this to this. But it is not exact. Why it is not exact? Because there is a negative 2 here. There is no negative 2 here. Okay, there is no negative 2 here. So for it to be exact, we will insert negative 1/2 outside. We will take the reciprocal of negative 2. The reciprocal of negative 2 is negative 1/2. Right? So it will be something like this. We'll place negative 1/2 here. And for it to pull under the exact power formula, there should be negative 2 here. Right? So negative 1/2, negative 2 actually cancels. A minus minus is still a plus within change value. And here, there is also a negative 1/2 here. And there should be a negative 2 here. Negative 2. Okay? The operation here is subtraction, right? There is a subtraction here. We insert negative 1/2. So negative 1/2 times negative 2, it's still 1 within change value. But for the first one and second one to fall under the power formula, we must have to insert negative 1/2 outside, negative 1/2 outside. After inserting negative 1/2, we can use this one now. And the integral of the power formula is actually u to the n plus 1 over n plus 1. Okay? So integrating this one now, this will be negative 1/2. The integral of this one, it falls under this. The value of u is cosine of twice theta. 3 plus 1 will be 4 all over 4. Minus the operation here is subtraction. we inserted negative 1 half. So negative open quantity, negative 1 half. This is very critical because if you miss your quantity thing, you will be wrong on the side. So negative open quantity, negative 1 half, we insert negative 1 half. And the integral of this, it still follows the power formula. The value of u is cosine of twice theta. Okay? It will be, the power now will be pi plus 1. This will be 6. Okay, all over 6. Close bracket, this is plus c. And if we try to simplify, this 2 here is under the denominator, so that will be a. But this is negative, so the coefficient of the first answer will be negative 1a. Cosine to the fourth of twice theta. This 2 here is under the denominator also, and so it is. So the denominator will be 12, but the proper sign will be, this is negative, open quantity negative. So a minus minus, that will now be plus. So the coefficient of the second answer will be 1 over 12, cosine to the 6 of twice theta plus c. So this will be our answer. Okay, that's it, guys. That's how we solve integration involving powers of sine and cosine by using our knowledge of the so-called trigonometric identity. Sine square of theta plus cosine square of theta is equal to 1. Then we'll try to change the angle, because what is the given angle is twice theta. It is not just simply single theta. Okay, if this is theta, this should be theta. If this is twice theta, this should be twice theta. So replacing theta by twice theta, it will become sine square of 2 theta will be equal to 1 minus cosine square of 2 theta to satisfy this problem here. Okay, that's the solution. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.